Welcome back, students. Let's take up the third problem in drawing number 7. This is also on simple position 2, but this is on a circular lamina. This is a circular lamina. When you take a circular lamina, there are no edges, so there are no corners. It is just curved. The surface is curved here. Okay. When you are dealing with the other polygons, you had the luxury of connecting the points just by straight lines. You just used to get the straight lines wherever the locus and projector intersects. You just mark the points and just connect all the points using straight lines. So you can use a scale and connect them. But here you don't have any edges on a circular lamina. So you have to use freehand to connect the points. Okay, that is the difficulty when you get a problem on a circular lamina, and it takes time as well. Okay, so when you are given, I would say you are a little unlucky when you are given a problem on circular lamina in the exam, because the points have to be connected using freehand. That is one thing. You may not be very good at that unless you are perfect with your the control. You should have proper control in drawing the curve. That is one thing. And normally we divide the circle into 8 equal parts. So you will have 8 points on the circumference so that you can conveniently connect them. That will also consume time. Okay. So when you are given a problem on circular lamina, it will definitely consume more time compared to the other problems. So no corners in a circular lamina. Let us read out the problem. Let me take up the problem. The problem number is 2.3.6. Video primer number 48, drawing number 7. A circular lamina of 50 mm diameter. One important point, very important point. It is given that the diameter is 50. I have seen many students taking 50 mm as radius and drawing the circle. 50 mm is the diameter, so the radius has to be 25. Okay. So be careful about this. When you are given a circular lamina, normally diameter only is given. Radius will not be given. You must take the radius as 25 while drawing the circle. It is resting on HP such that one of its diameter is inclined at 30 degrees to VP. That's the VP condition. And the same diameter is inclined at 45 degrees to HP. Now, where are the conditions that to be given in the problem for you to adopt SP2? Where is the condition that the lamina is resting with a corner on HP? There is no corner for a circle. There is no corner. There is no edge. I'm sorry. There is no edge for a circle. Okay. So if at all, if it is resting on HP, it can rest only with a corner. So that condition need not be given in the problem that the circle is resting with an edge on HP. There is no edge first of all. So it is just mentioned that it is resting on HP. So it need not be given that it is resting with a corner on HP. That's not required when it is a circular lamina. Okay. So let us assume, let us take it as it is resting with a corner on HP. Then where is the condition that the surface is inclined to HP? It is indirectly given. It is given that the diameter is inclined to HP at 45. If you take the circular lamina, okay, let us take this extreme right corner on the right, and then you make it inclined. Let us say this is the diagonal. So when you make the surface inclined to HP, the diagonal also will make the same inclination with HP. So both have the same meaning. Instead of saying the surface is inclined to HP at 45, I can say this diameter is inclined to HP at 45. They have the same meaning. So both the conditions that are required for you to adopt SP2 are there. Maybe indirectly they are there. In the previous problem, the conditions were directly given to you so that you can easily identify that it is SP2. But here the conditions are indirectly there. And if you read the problem, the VP condition is given first. What's the VP condition? The diameter is inclined at 32 VP. That's the VP condition. That is given first. But do you satisfy VPC first? No, because it is SP2. When it is SP2, you should satisfy HPC first. What is HPC? The diameter is inclined at 45 degrees to HP. Okay, so start with SP2, start with the top view by drawing a circle in the top view. And because you don't have any corners here, what do? We divide the circle into 8 equal parts. 8 equal parts means 360 divided by 8 will give you 45. So each angle will be 45 degrees when you divide the circle into 8 parts. So let me draw a circle with 25 mm radius first. That means the diameter has to be 50. Divide it into 8 equal parts. These are 4. The angles are 90. Now 2 more diameters. Now each of the angle will be 45 here. Okay. Let us represent the diameter of the circle. It is represented by 5. We write it as 550. 550. 5 means diameter. So when you use the software, this will automatically come when you choose a smart dimension. Now you need to name these corners. I'll start from here. A, B, C, D, E, F, G, H. Eight parts. I'm sorry, I think I mentioned it as 6 parts. It should be divided into 8 equal parts. 360 by 8 is 45. Okay. Okay. Now let us draw the projectors from all these corners, from all these points, so that you can draw the front view. The front view is a line and the line is on XY line. Name the points. This is A dash. B is visible, H is invisible. So B dash, H dash. Next C visible, G invisible. C dash, G dash. Then D dash, F dash. And finally E dash. So there are 8 points. 6 plus 2, 8 points. This is how the front view appears. Now what do? You rotate the surface inclined at 45 degrees. Make it inclined at 45 degrees to XY. The rotation will happen about the point A. You will keep that point A, that is the support on HP. It is just resting with the corner on HP. Okay. So this is the surface. This is how you started. You can put it in any position because it's a circle. You can put it in any position on HP. Okay. When you keep it on HP, the extreme right corner is the point of interest to you. This point. We are taking it as A. In the first step, the top view appears to be a circle and the front view appears to be a line. When this is projected on the front wall, what do you get? You get a line. And the length of the line will be equal to the diameter of the circle. This is nothing but 50. This length will be 50. And what are you doing in the second step? This point A you are keeping on HP and you are making the surface inclined at 45 degrees to HP so that diameter AE is the diameter. Here you can see. The diameter AE will be made inclined at 45 to HP. That's how it is given in the problem. Okay. So what do? take A dash, make sure you have enough space for the third step. A dash on XY and draw this line which is equal to 50 mm in length, inclined at 45 degrees to HP. Just take these distances with compass, go on marking the points. This length should be 50. So show the angle, it's 45. So what you are given is the diameter AE is inclined at 45 degrees to HP. In other words, the surface is also inclined at 45 degrees to HP. Both are same. So when the surface is inclined at 45 degrees to HP, how does the top view appears? How does it appear? Can you imagine in a circle? This is the surface. You are making the surface inclined at 45 to HP. What will be the top view? It will be an ellipse. The top view will be an ellipse. And you have to draw it freehand. Okay. Let me get the points first. You have to get 8 points. This is the projector of A. Locus of A, wherever they intersect you get A. Similarly B and H. This is B, this is H. Then G and C. C, G. Next D and F is the same. So this is D, this is F, and finally E. Okay, you need to connect all of them using freehand. And when you are drawing the freehand curve, it should appear continuous curve. There shouldn't be any breaks in between. Okay, you shouldn't have any breaks in between. This is how you should draw. Draw a freehand curve. This is how the top view appears. It appears to be an ellipse. So, in the first step, it was SP2. In the second step, you satisfied HPC. Now let us check what is the VPC. What is the VPC? It says the diameter is inclined at 30 degrees to VP. Which diameter? The same AE, whichever you have made inclined at 45 degrees to HP. This one, the same diameter is inclined at 30 to VP. So is it the true angle or apparent angle? It is true angle. What is mentioned? The diameter is inclined at 30 degrees to VP. There is no term like appears to be inclined, or there is no term like top view of the diameter inclined at 30 degrees to VP. There is nothing like that. Straight away it is given the diameter is inclined at 30 degrees to VP, so it is true angle. But is the diameter AE in its true length? Is the diameter AE in its true length? Is it the same as this? This is the true length of AE. No, it's not true length. It is apparent length. So you have apparent length, but the angle is true angle. So you need to find beta. Once again, okay? We need to find beta. The beta is what? Apparent angle. What is the apparent angle corresponding to this apparent length is what I need to find. So what is true angle? True angle is 30 degrees. So let me start by drawing the true angle first. It is 30 degrees. Okay. Corresponding to this, I must find the apparent angle now. Because it is true angle, I will mark the true length of AE on that. AE is the diameter of my interest now. Okay. So while this you must take this length from this step, true length. So I'll keep it somewhere here, A, and because it is true length, I will call it as some E1. That's the true length of AE, which is equal to 50. So you can dimension it, just for your understanding. This is 50. Now what to do? To find the apparent angle, you draw the locus of E1. Just draw a line parallel to XY. Now take its apparent length, A to E. Okay. Take this with compass, A as center, cut this. So this is apparent angle. That when you measure, it should come to 45 degrees. Even when you are doing it manually also, it should come close to that. 45, 44, 46, 1 degree error is accepted. But when you do in the system, it should come to 45. No change. Okay, now comes the most difficult part of this problem. You have just 2 points with you, A and E. You need to get the remaining 6 points. Just you can make use of the compass to get the 6 points. I will tell you the procedure for 1 point. See, let us say you want to A and E you have. Let us say you want to get H. What do? Just make use of your compass. A to H, take the radius, draw an arc here. E to H. From E to H you measure it. Okay. Take E as center and EH as radius. Cut it. You get H. Similarly, you can get all the points. Okay. Just making use of the compass. Get all the points and draw an ellipse passing through all of them. Okay. I will do it by drawing perpendicular lines here. This is the middle one. So I take this distance G and C. Next, I measure this distance, draw another perpendicular. These perpendiculars are being drawn to AE, not to AE1. Please be careful. Okay? You are drawing the perpendiculars to AE, not to AE1. Measure this distance from the center to B and from center to H. So the right half is done. Now do the left half. Mark this distance, measure this distance and draw a perpendicular. So from the center, you can take this distance. This will be for D and this will be for F. Both will be equal. This is D and you have F here. And E is here. Passing through all the 8 points, you have to draw a freehand curve. This is where the challenge lies for you to draw the curve. Okay, you should draw it quite smooth. The curve should be quite smooth without any breaks in between. So you need to practice that. It doesn't come so easily. Okay. So that's how the top here appears. It's an ellipse, an oval in shape. So you got the top view, now you need to project and get the front view. Once again, 8 points you need to project and draw the locus from these points. Their intersections will give you the final front view. Let me draw it and show to you. Let me start with A. This is the locus of A. So A dash. Draw the locus for B and H. Project B and H up. This is B dash and H dash. then comes the point C and G, C dash, G dash. Next D and F. Draw the locus first and then draw the projectors. D dash, F dash. It's better to do like this, okay, step by step. Don't don't draw all the locus lines at a time and don't draw all the projectors. You will go on searching where the intersections are. It's better to go step by step. 2 points, you have drawn one locus, then project them, mark them. It's better to do that. And finally E dash. Here you have E, draw its projector. Okay. So you will be connecting all of them using a freehand curve once again. This will also be an ellipse. Okay, that's how the final front view appears. Okay. It depends on this angle. Okay, this angle is given 45. Okay, so that's how it appears. So this is about the circular lamina problem. Circular lamina with the apparent angle beta will consume more time. Okay, had it been true length and true angle, it wouldn't take much time. Okay, I need to find beta first, then drawing the arc. Here also an arc. This is also an arc. Drawing freehand arc will consume time. So this problem definitely consumes more time compared to the other problems. But yeah, as I mentioned already, if you are finding some angle, it's better to state it. Where whatever the angle is found, it's better you mention it. Okay, sometimes the examiner expects that it has to be shown. Even if you show the angle here, it's better to show it. You can show it as beta is equal to 45 here. So this is VPC, vertical plane condition. So that's it, students. With this we complete drawing number 7. From drawing number 8 onwards, the videos that I show, I have made those videos with straight away drawing on the sketches on the book only. I have drawn the sketches on A4 size sheet. That was done during the lockdown period, last semester itself. So I didn't have this board at that time during lockdown period. So I had made the sketches on the book only, and that was video. Okay. So from drawing number 8 onwards, the videos have already been made. They're really there with me in YouTube, in my channel. So I'll be sharing the links to you. Till here it was done offline during last semester. That's when this corona period has come, and then we continued with only online classes. And for you, it is completely online class. Okay. Let's hope you are going to come back to the college. That will be more convenient for me and for you as well, instead of watching the. But even at that time, I will be sharing the links to you, video links, so that if you miss a class or you have not followed some point, you can watch the video again and get the concept clear. So that's it, students. We have finished drawing number 7 now. There are some drawings which are given as assignment in the question bank. Keeping the offline classes, we mentioned it as assignment, but now it's all assignment to you. So even those drawings you need to draw and submit in the Google Classroom. Okay. So normally I don't give any last date for them to submit. So if it comes up, for example, 6, 7, 8, 9 will be done in the class. I think 10 is an assignment. drawing number 10 is an assignment. So I won't be mentioning the last date and all for that. You need to, do it and submit it. But I'll create an assignment for you in the Google Classroom. Against that, you can submit the assignment. Okay, let's stop with that. And once again, I'll come back with drawing number 8. As I already told, it is already videographed. That it's already available in my channel. Okay, see you there.